So welcome everyone. Let's start today's topic that define as deflection of beam, right? So let's first understand what is deflection of beam. It is a simple statement like when a beam with a straight longitudinal axis is loaded by lateral forces, the axis is deformed, right, into a curve, and it is called as, this phenomena is called as the deflection curve of the beam, right? So as per the statement, when you have a longitudinal axis and it is to be loaded by, when you have a longitudinal axis and is to be loaded by lateral forces, the axis is deformed. Into a curve, and that curve is defined as deflection of the beam. So basically, in this chapter, we will determine the equation of the deflection curve, and also find deflection deflections at specific points along the axis of the beam, along the axis of the beam, right? So in this chapter, the first objective is to determine the equation of the deflection curve, right, at different specific points along the axis of the beam. So that is the first thing that we need to find or calculate in this chapter, right? Now, why we want to find or determine the equations of the deflection? Because the calculation, you can say the calculation of deflection is an important part of structural analysis. Structural analysis and design, right? These deflections are also important in dynamic analysis. Suppose if you are going to investigate the vibration of aircraft or the response of a building to earthquake, So these are the calculation is very much important. If load is applied any beam, then what could be the maximum deflection? That information you have to know, and based on this information you define or design the analysis part, right? So this is the importance of this chapter. So moving to the next one, so I'm going to define the heading, that the first heading that we are going to understand, like in the previous, the first topic that we are to determine the equations of the deflections, right? So when you're, how you are going to define the equations of the deflection curve, that is when you define something. So the first topic that we are going to study is your differential equation of the deflection curve. अगर हमको ये डिफ्लेक्शन कर्व का डिफरेंशियल इक्वेशन पता है तो हम हर एक पॉइंट पे कितना डिफ्लेक्शन आ रहा है we can calculate easily, right? So let's take an example. Let's take a simple example. Suppose a cantilever beam is loaded by a point load P, right? So this is the cantilever beam and it is loaded by a point load, and based on this, so what are the condition that is going to be arise in this case? Let us see. So this will be your y-axis, this will be your x-axis. So when a point load is applied at the free end, or you can say that at the extreme end of the cantilever beam, it will deflect something like this, right? So just take some, this is V, is the deflection at any distance of x, right? So V is the deflection at the distance of x is defined. So we need to first set up the relation of deflection with respect to x, right? So we are going to define that is, what is V? V is the displacement in the y direction of any point on the axis of the beam, right? Here y is considered, y axis is considered positive when upward, right? Therefore deflection is also positive when upward, right? So these are the conditions that we have defined. Based on this criteria, let's obtain, so we are going to define to obtain the equation, of the deflection curve. To obtain the equation of the deflection curve, we need to express deflection, that is V as a function of x, right? Okay, so let's understand this term first. So this is, suppose this is the deflection, So we are defined at x. This is what the x distance, and for a small distance, that is dx, this is the point which is defined as m1, right? So m1 point denotes a deflection of v at a distance of x, right? Similarly, there is a point m2 which is away from m1 at a distance of dx, and this m1 have deflection v plus delta v, right? So this is the deflection in y-axis at m2, it is v plus delta v, and m1, the deflection is m, right? So based on this, we have defined one curve, something like this. So this angle is defined as, suppose, delta theta, right? So we have defined what is delta v. Delta v is the increment in the deflection. डेल्टा v क्या है? एक आपका इंक्रीमेंट है डिफ्लेक्शन का as we move along the curve, as we move along the curve from m1 to m2, right? So similarly, we have defined in this curve, if we are going to zoom it, this part, so what will we get in an enlarged view, that we are going to understand what will happen. It will behave like a curve, something like curve, right? On this axis, let's draw this axis, and this is the m1 point, and this should be the m2 point, right? So the slope is defined here, it is at theta, and the slope at this particular point is defined as theta plus delta theta, and this is the angle, it is defined as delta. So, and this is the, suppose this is the intersection of these two, which is defined as O dash, right? So from this point to this point, it is defined as a distance of dx, and from this point to this point, this is of delta v, because this is v and this point is v plus delta v. This is v, this is v plus delta v. So this is point is delta v, right? And the curvature along from distance from m1 से m2 तो हम क्या बोलते हैं? ds, right? So remember one thing with respect to the sine curve, like whenever upward right hand side, it is defined as a positive, and upward positive, and right hand side it is defined as a positive. Similarly, if it is of anti-clockwise, it is defined as a positive, and if it is a clockwise, it is defined as negative. So these are the with respect to the sign conventions, right? So what will happen? Let us see these conditions. So when a beam is bent, there is not only a deflection at each point along the axis, but also a rotation. So delta theta is defined as a rotation. So we are going to write this term like when the beam is bent, there is not only a deflection at each point, along the axis, the but also a rotations, right? So therefore अगर आप rotations को बात कर रहे हो तो इसका मतलब इस normal के एक आपने जो दो point of intersection हुआ तो वो center of curvature कहलाया, and the distance from this point to M1 and M2 is defined as the radius of the curvature, right? So the point of intersection of these normal is defined as the center of curvature. So this is defined as the center of curvature, and R is defined as the radius of curvature. So based on this information, you already know that ds is the distance. So if we consider a distance like arc, so we all know with respect to the geometries that arc is defined as r theta, right? R theta. That is the information we have. So based on this criteria, can we define ds? ds is equals to r d theta, right? But important point ये याद रखना कि d theta should be in radian. So that is one of the most important information कि d theta यहाँ पे आपको radian में रखना है, because it is ds is always in this conditions, right? And what is ds? ds is a distance between m1 to m2. So let us define one. It is defined as the curvature. What is curvature, right? If we define curvature, so curvature is a measure of how sharply a beam is bent, right? What is the meaning of curvature? कि कितना ये आपका beam कितना sharply bent हो रहा है, that term is defined as a curvature, right? And you always remember that curvature is always the inverse of your radius. So if k is 1 by r, it means what? 1 by r is defined as d theta by ds from this equation. Yes or no? So if we want to know कि हाँ भाई curvature क्या है, तो curvature is a you can say d theta by ds को represent curvature, और curvature is also defined as inverse of the radius. So that is the information we need to understand. So moving to the next one, now we are going to define the slope of the deflection curve, right? So let's understand what is the slope of deflection curve, right? So when we talking about slope of the deflection curve, it is the first derivative. It is the first derivative, that is dv by dx of the expression for the deflection v, right? The slope, you can say the slope, that is dv by dx, is also defined as tangent of the angle of rotation, right? So you can see this conditions. This is basically dx, right? This is basically dv. So this is the tangent, because ये जो आपका dx और dv है बहुत small है, so we just consider that is dv by dx is equals to tan theta. So that is the tangent of the angle of rotation. It is defined as dv by dx is equals to tan theta. So based on this, you can also find out what is the angle of that one. So that theta can be defined as tan inverse of dv by dx. Yes or no? Now, this triangle, if we consider this triangle, this is your theta, this is your ds, this is your dv, and this is your dx, right? So आप इसकी conditions क्या लिख सकते हो भाई? Cos theta can also be defined as dx upon ds. Similarly, sin theta can also be defined as dv by ds. Because of delta v and delta x, these are very small quantities. So the important point यहाँ से ये निकल के आया पहला कि आपका जो delta v by delta x है, that is defined as a tan theta, right? So above equations, we can say that कि above equations are based on geometric consideration, right? What does it mean? It means if everything depends on the geometric, then this equation valid for beams of any material. Therefore, this equations are valid for beams of any material. What type of material you are using, that is insignificant with respect to these equations, right? Now, based on this criteria, if I say beam with a small angle of rotation, what does it mean? So when we're talking about the small angle of rotations, तो अगर आप इन चीजों को समझने की कोशिश करो, तो एवरी डे टू डे एक्टिविटीज में जो स्ट्रक्चर्स है, स्ट्रक्चर्स जैसे आपका बिल्डिंग्स हुआ, ऑटोमोबाइल्स हुआ, एयरक्राफ्ट हुआ या शिप्स हुआ, वो स्मॉल चेंजेस शो करते ही करते हैं. कैसे? भाई उसमें लोड लग रहा है, तो व्हेन इट इज अप्लाइंग लोड, तो उसमें क्या होगा कि स्मॉल डिफ्लेक्शंस तो होगा ही होगा. अब उससे क्या होता है? ठीक है, व्हेन इट्स चेंज इट्स शेप व्हाइल इट सर्विसेज, तो कंसीक्वेंटली the deflection curve of most beams and columns have very small angle of rotation. मतलब उसमें क्या है कि जब उसमें स्मॉल चेंजेस इन शेप होगा तो डिफ्लेक्शन भी कम होगा. यस, जब डिफ्लेक्शन कम होगा तो उसमें स्मॉल एंगल ऑफ रोटेशन होगा, इसमें स्मॉल कर्वेचर होगा. यस और नो? तो अगर हम वो कंडीशंस क्राइटेरिया बनाएं कि आपके बीम में स्मॉल एंगल ऑफ रोटेशन हो रहा है, राइट? So it means what? Theta is very small quantity defined. Theta is very small quantity defined. Yes. So practically, if theta is very small, can we say that ki cos theta, which you have already defined here, cos theta is equals to nearly equals to 1, which it means the values of dx is also equals to ds, right? If the ds is equals to dx, then with respect to the curvature k, we have defined it is a ratio of 1 by r, which is also defined as it is a ratio of d theta by ds. But now theta is very small, ds can be equivalent to dx. So it means that d theta can also be written as dx. Okay, so this is basically the first equation we'll obtain from this expression, right? Now, based on the second criteria, therefore theta, here we have already defined tan theta, right? So if theta is small, then tan theta is also equals to theta, which is defined as dv by dx, right? So we can assume that the angle of rotation theta and the slope, that is dv by dx, are equal. Important point here, it is again that theta should be in radian. That is the note we need to remember. Okay. So taking the derivative of theta with respect to x. Now, again, taking derivative of theta with respect to x, what we'll get? D theta by dx is also equals to, that is the second derivative of d square v upon dx square. So when we have a beam with a small angle of rotation, then d theta by dx is also to be written as d square v upon dx square. This is the second equation we obtained from this guy, right? Now, combining equation number 1 and equation number 2, we will get, that is k, which is also to be defined as 1 upon r, which is also to be defined as d square v upon dx square. Now, the beauty of this equation is that this equation is valid for beam of any material. Provided the rotations are small quantities, right? Now, if I say, if the materials, if the material of a beam is linearly elastic, if the material of the beam is linearly elastic and follows Hooke's law, then the curvature, in terms of the bending moment in the beam, is defined as, then the curvature in terms of the bending moment, that is k, that curvature, that k, is defined as 1 by r, which is also equals to m upon ei. What is ei? The product of ei is defined as your flexural rigidity, right? So this is the another equation. So we can say that this is your equation number 3, and this one is your equation number 4, right? So the combining the equation number 3 and equation number 4, we obtain the differential equation of the deflection curve of a beam. That is your d square v by dx square is equals to m upon ei. This is the differential equation This one is a differential equation of the beam. This one is a differential equation of the beam curve, differential equation of the deflection curve of the beam. Now class, remember one important thing is that if I'm telling you that this is the differential equation curve, so remember one thing, that this curve, this equation basically, d square v upon dx square is equals to m upon ei is segregated in two parts. How this equation has been segregated in two parts, let's understand. When you have a prismatic beam, now what is the meaning of prismatic beam? Prismatic beam defined as when you have your flexural rigidity is constant, right? Then equation is defined as ei d square v upon dx square is equals to m, right? What does it is defined segregated in two parts, prismatic beam and non-prismatic beam. So I believe you all understood what is the non-prismatic beam. Non-prismatic beam, that the flexural rigidity is not constant. It means it is variable, right? If it is variable, then equation is to be written like eix d square v by dx square is equals to. Is that clear to everyone? So there are seven methods by which there are seven methods to find deflection of a beam. To find deflection of beam, right? The first method is defined as your double integration method, which is defined as double integration method, right? To find deflection anywhere. This method by which you can find deflection anywhere, right? The second method, which is defined as Macauley's method. Macauley's method, which is known as several point load method, right? Okay. The third method that will see in this case is moment area method. That is defined as a moment area method. These are the scope of study we'll see in the coming slides, right? And the fourth method is defined as method of superposition. There are a number of methods, but the deflection due to them could be found individually. Okay. The fifth method that we'll see is the conjugate beam method. Conjugate beam method, right? The sixth one is defined as your Castellano theorem. Castigliano theorem. And the seventh one is defined as your work energy method. It is defined as a work energy method. Right? So these are the seven methods. Based on this, we can find the deflection of the beam. Let's start the deflection of the beam first by double integration method, right? So we'll see how this method works, which is defined as double integration method, right? So let's understand. Just take an example. We have defined as a cantilever beam with point load, right? Cantilever beam is defined as a point load. So just see this condition in this double integration method. We can see that there is a point load which is acting at the end of the beam, right? This is the distance of the beam, and we need to find the moment at x distance, right? Always just tell me one thing, class. Can anyone tell me, this is the two end, this is end A and this is end B, right? At end B, at B end, can you tell me what is the deflection of the beam? कोई मुझे बताया क्या? What is the deflection at the end B? What is the deflection at B? Bhavesh? ये कैंटिलीवर बीम है और इस कैंटिलीवर बीम में एक एंड फिक्स है, तो इट मींस व्हाट कि जब आप इस पे पॉइंट लोड लगा रहे हो तो देयर शुड नॉट बी एनी डिफ्लेक्शन एट पॉइंट बी, राइट? सो डिफ्लेक्शन एट द पॉइंट बी शुड बी जीरो. Yes or no? Likewise, its slope, that is dy by dx, is also to be zero at end B, right? If you see that, this curve will behave something like this. So you can see that there should not be any deflection, there should not be any slope at this particular point, right? Okay. So let's see this condition, right? What is the moment at x section? So we can see that mx, that is a moment at section x, is defined as minus p into x, right? So based on this, we are going to find the deflection. हमें deflection calculate करना है. तो हमको सबसे पहले क्या है? Differential equation जो हमने define की, that is ei d square y by dx square is to be defined as m of x, right? Now you can put this values of minus px. ठीक है? अब इसको आप इक्वेशन को सॉल्व करोगे तो फर्स्ट इंटीग्रेशन यू विल गेट कि ei dy by dx is equals to minus px square by 2 plus of c1, right? तब कांस्टेंट वैल्यूज यहाँ पे आ गया c1. अब यहाँ पे आप देखो, टेल मी वन थिंग, at x equals to l, जब ये x की वैल्यू इस पॉइंट पे डिफाइन करती है तो when I say at x equals to l, your slope जो dy by dx है, that is dy by dx is also to be defined as 0. Yes, you have already defined this values. When x is equals to l, dy by dx equals to 0. So in this case, you put this value 0 and here in this case l. तो आपकी इक्वेशन क्या बनेगी? ei into 0 is equals to minus pl square by 2 plus c1. It means what? The value of c1 is defined as pl square by 2, right? So we have defined this equation like ei dy by dx is equals to minus px square by 2 plus pl square by 2. So that is the first equation we have obtained from this condition. Now class, see this condition. So this is the maximum at x equals to 0 पे अगर आप देखने की कोशिश करो at x equals to 0 पे क्या यहाँ पे मैक्सिमम स्लोप आपको नहीं मिलेगा क्या इस पॉइंट को अगर आप देखो तो yes or no? So this is the maximum slope. So what is the value of maximum slope at x equals to 0? We can see that put this value x equals to 0 in this equation, you will get that is EI. Your dy by dx is defined as a theta max, right? Which is also to be defined as ये value 0 हो जाएगी, equation ये values क्या बनेगी PL square by 2. It means what? The maximum slope आपको जो मिलेगा वो क्या होगा? That is theta max की value is defined as PL square upon 2EI. This is the maximum slope we have obtained at x equals to 0. Right? Okay. Now, integrate this equation. This equation number 1. You further integrate. अब आपको क्या चाहिए पहले आपको क्या मिला स्लोप मिला अब आपको क्या चाहिए मैक्सिमम डिफ्लेक्शन की मतलब इस एक्सिस से डाउनवर्ड डायरेक्शन में कितना ये y वैल्यू है मैक्सिमम दैट वी हैव टू डिफाइन राइट फॉर दैट वी हैव टू इंटीग्रेट दिस इक्वेशन फर्दर तो हमने जब इंटीग्रेट इसको फर्दर किया तो व्हाट वी गेट वी हैव डिफाइंड ei y which is also defined as minus p x square का हो जाएगा x cube by 2 into 3 that is 6 plus pl square by 2x plus c 2 right now see this condition this is the equation we have put we obtained तो हमने बोला कि चलो at x equals to l अब यहाँ पे l का मतलब है कि b end तो b end पे y की वैल्यू क्या हो रही है 0 it means what at x equals to l the value of y is also 0 मतलब there is no deflection at fixed end so it means what this equation is defined as 0 is equals to minus pl cube by 6 plus अब यहाँ पे देखो pl square है ये l हो जाएगा that is also defined as pl cube by 2 plus c right now can anyone tell me what is the value ये आपकी वैल्यू ये c2 की वैल्यू कितनी हो जाएगी c2 is defined as equation solve किया that is minus of pl cube by 3 so finally you get an equation आपको एक equation क्या मिली that is ei into y is equals to minus px cube by 6 plus pl square by 2x minus pl cube by 3 so this is the equation we obtained from this expression right आपको अब ये इक्वेशन तो मिल गई दिस इज यू कैन से द इक्वेशन नंबर 2 अब based on equation number 2 put x is equals to 0 because you see that the value of x equals to 0 at this point you will get the maximum deflection yes or no when you put the value of x equals to 0 what you will get ये value 0 हो गई ये value 0 हो गई ये values बची so you can define that ei अब ये क्या हो जाएगा y max right which is also defined as minus pl cube by 3 which is also to be defined as y max is equals to pl cube by 3 ei अब माइनस साइन हियर शोज व्हाट कि ये डाउनवर्ड डायरेक्शन में है ये तो शो कर रहा है माइनस साइन ठीक है लेकिन मैक्सिमम डिफ्लेक्शंस का मतलब कितना कि मैग्नीट्यूड कितना हुआ दैट इज pl cube by 3 ei तो अगर इसका अगर हम मॉड ले लें तो दिस आल्सो टू बी रिटन एज इन टर्म्स ऑफ डेल्टा So that is deflection delta max, which is to be defined as DLQ upon 3 EI. This case is cantilever beam with a UDL, right? So based on this, let's define as suppose W kilonewton per meter load is acting at this particular point, and this is at X distance. So we all know that is a UDL. So its load of application is defined also as X by 2. The total load at X section is defined as WX. Therefore, the moment Mx in this case is defined as minus Wx square by 2, right? So it means what? It is also to be defined as, if we take, that is d square y by dx square is equals to minus wx square by 2, right? Now double integrating it with it. So what we'll get, ei dy by dx is equals to minus wx cube by 6 plus c1, right? So same ways at x equals to L, your dy by dx is equals to 0, right? Therefore, we can define here in this case. अब यहाँ पे dy by d की value 0, this equation is 0 at x equals to this one. So it means what? कि यहाँ पे जो c1 की values है, that is defined as WL cube by 6. So c1 here it is to be written as WL cube by 6, right? Okay. So the equation we have defined is like ei dy by dx is equals to minus wx cube by 6 plus WL cube by 6, right? Now put x equals to 0, that is the maximum deflection, maximum slope is at x equals 0. You will get theta max, right? So what is the value of theta max? That is to be defined as ei theta max is equals to, this will be 0, that is defined as WL cube by 6, which is also to be defined as theta max is equals to WL cube upon 6 EI, right? Okay. Now the next case, integrating again. So if we integrate this expression, that is 1, so what we will get? We will get EI by minus x to the power 4, 6 into 4, that is 24, plus WL cube by 6x plus C2, right? Now, at x equals to 0, y should be 0, because there should not be any.
At x is equal to L. Huh?
Yes, at x equals to L. Yes, class. At x equals to L, y should be 0, right? So this expression can be defined as the value of C2 can be written as minus WL to the power 4 by 8, right? So your expression is defined as EIY is equals to minus WX4 by 24 plus WL cube by 6x minus WL to the power 4 by 8, right? Now at x equals to 0, you will get the maximum deflection, right? So put the values of maximum deflection at x equals 0. What we will get, EIY is equals to minus WL to the power 4 by 8, right? Therefore, delta max is also to be defined as minus WL to the power 4 8E5. Class, is it clear to everyone?